Welcome to Z. Today, we're diving deep into one of the most breathtaking natural displays on Earth, auroras. These captivating light shows, often gracing the skies in polar regions, are a stunning testament to the complex interactions between solar activity and Earth's atmosphere. Join me as we explore the science, history, and sheer magic of auroras, uncovering why they continue to inspire awe across generations. Auroras, known as the Northern Lights or Aurora Borealis in the Northern Hemisphere, and the Southern Lights or Aurora Australis in the Southern Hemisphere, are mesmerizing phenomena that result from charged particles from the Sun colliding with gases in Earth's atmosphere. These collisions create a breathtaking light display, often appearing as shimmering curtains or waves of color that ripple across the sky. The most common colors include green, pink, red, yellow, blue, and violet. Let's break down the science of color. When charged particles collide with oxygen at lower altitudes, generally around 100 kilometers, bright green hues dominate. As we ascend higher into the atmosphere, around 300 kilometers, oxygen can emit red and purple colors. Interestingly, nitrogen can produce purples, blues, and pinks, depending on the altitude and the type of interaction. This palette of colors adds to the ethereal beauty of the aurora, making every display unique. Picture standing on a frozen expanse, surrounded by silence, when suddenly the night sky bursts into vibrant life. Waves of green, shimmering like silk, dance alongside flickering purples and reds. This experience is more than just a visual spectacle. It connects us to the elemental forces of nature, reminding us of our planet's dynamic environment. The genesis of auroras begins with solar activity. The sun constantly emits a stream of charged particles known as the solar wind. During solar storms, triggered by solar flares or coronal mass ejections, this wind intensifies dramatically. When these charged particles approach Earth, they encounter the planet's magnetic field, which serves as a protective shield. This magnetic field channels the particles toward the polar regions, creating an auroral oval where the lights are most often observed. Once the particles are funneled into the atmosphere, they collide with gas molecules. This collision excites the molecules, causing them to release energy in the form of light. Think of the sun as a massive engine, continuously firing particles into space. When these particles reach Earth, they don't just drift away. They set off a spectacular light show, connecting us to cosmic events happening millions of miles away. Auroras are predominantly visible near the polar regions, within a zone called the auroral oval. The northern lights can be spotted in countries like Norway, Sweden, Canada, and Alaska, while the southern lights are visible in Antarctica, New Zealand, and parts of Australia. The ideal time to witness these phenomena is during the winter months, when the nights are long and dark. However, auroras can occur at any time if solar conditions are favorable. During strong solar storms, even regions far from the poles may be treated to glimpses of the auroras. Imagine embarking on a journey to a remote Arctic village. As dusk descends, the air becomes crisp and the landscape transforms into a winter wonderland. You gather with fellow adventurers, eyes trained on the horizon, waiting in anticipation. Suddenly, the sky lights up with brilliant colors, a mesmerizing display that connects you not just to nature, but to the universe itself. Throughout history, auroras have held profound significance in various cultures. Indigenous peoples of the Arctic, such as the Sami in Scandinavia and the Inuit in North America, have woven rich folklore around these lights. For the Sami, the lights represent the souls of their ancestors dancing in the sky, a celebration of life and remembrance. Inuit cultures have viewed auroras as the spirits of animals, signifying important events in their hunting traditions. These cultural narratives reflect a deep relationship with nature, where auroras symbolize hope, guidance, and continuity. As modern society has evolved, so has our relationship with auroras. Today, they inspire artists, poets, scientists, and adventurers alike. The ethereal quality of these lights invites creativity, often depicted in artwork and literature, illustrating humanity's enduring fascination with the natural world. Imagine walking through an art gallery filled with paintings of auroras, each piece telling a story of the artist's encounter with these lights. The emotional resonance is palpable, showcasing how auroras continue to inspire and shape our cultural narratives. Auroras are intricately linked to the broader phenomenon of space weather. Solar flares and coronal mass ejections can significantly amplify the solar wind, leading to stronger and more vivid auroras. Understanding space weather is vital, especially as it can affect modern technology. For instance, during intense solar storms, satellites can be disrupted, GPS signals may falter, and power grids can experience fluctuations. By studying auroras, scientists gain insights into these interactions, helping to safeguard our technological infrastructure. Picture scientists in a control room, eyes glued to monitors as solar activity spikes. They prepare alerts for potential disruptions, while also anticipating the beautiful light displays that might follow. The excitement is palpable, an interplay of caution and wonder, as they navigate the balance between protecting technology and marveling at nature's artistry. As our understanding of space weather advances, scientists continue to study auroras to delve deeper into the complex interactions between solar activity, Earth's magnetic field, and atmosphere. This research not only enhances our knowledge of auroras, but also informs us about the broader dynamics of our solar system. Future missions, including advanced satellites and ground-based observatories, will improve our ability to monitor auroras and their underlying processes. New technologies may allow scientists to capture real-time data on solar activity and auroral formations, providing richer insights into these captivating phenomena. Imagine a future where scientists can predict auroras with incredible precision, allowing people to plan their trips to catch the best views. The anticipation of witnessing the beauty of an aurora, combined with the knowledge that you're participating in a significant scientific endeavor, creates a unique sense of connection to the universe. Auroras are a stunning reminder of the dynamic relationship between the Earth and the Sun, showcasing the beauty of nature's light displays. As we continue to explore and understand these celestial wonders, we gain a deeper appreciation for the intricate dance of particles and energy that creates such awe-inspiring sights. Thank you for joining me on this journey into the world of auroras. Keep looking up. There's always more to discover in the skies above.